name is Yasser Jamal, and today we'll be talking about bisection method in computer sciences. And basically, basically bisection method is used to let's say we have an equation and we find the root of that equation, and we'll get two values. Most probably, in one is in positive sign and one is in negative sign. So basically, we just have to do a few iterations, and we have to put the negative negative answers in the negative bracket and positive answers in the positive bracket. That's pretty much how what bisection method is. So starting off, I'm joined by Muhammad Yaya Ansari and Sayyid Muhammad Abir Asim. And for the start, I would like Muhammad Abir Asim to start off with the slides.
Assalamu alaikum everyone. Welcome to our channel Tech Tribe Talks. So today our topic is basically bisection method in computer sciences. So I'll be covering the introduction slides. Then Yahya will be concluding the topic. So basically, the bisection method is a powerful numerical technique that is used in computer sciences to find the solutions of equations. And in this presentation, we will provide a detailed explanation of the method and its application. So moving towards the first slide, we got introduction to the bisection method. So the bisection method is basically a root finding algorithm which is systematically divided into interval unit. A root of an equation is found. It is simple and it is basically widely used in computer sciences. So, moving towards the next slide, we got the working principle and algorithms of the bisection method. So, it have a step-by-step algorithm which contains the section will be discussed the step-by-step algorithm of the bisection method, demonstrating how initial interval bounds are narrowed down until the roots of the equation is approximated. Now, moving towards the next slide, we got advantages and limitations of bisection method. So, starting with the advantages, the bisection method provides guaranteed convergence, and it is applicable to any continuous function, and it can also handle both real and complex number. Now, moving towards the limitations, we got while it is reliable, the bisection method is not the most efficient numerical technique, and it may require many iterations to achieve the desired accuracy. Now, moving towards the next slide, we got applications of bisection method in computer sciences. So the basically we bisection method contain three applications, and that is optimization problems, solving non-linear equations, and data analysis. So the first application is a optimization problem. The bisection method can be used to solve optimization problems by finding minimum or maximum points of function. Then solving non-linear equations, we got non-linear equations that cannot be solved algebraically can be approximated using the bisection method. And the last but not the least, data analysis. The bisection method is employed in various data analysis techniques, such as finding inflection points or determining the threshold. Now, the Yaya will conclude the topic and the presentation. Over to you, Yaya.
Assalamu alaikum everyone. As today we are discussing the bisection method. So I'll be explaining the bisection method comparison with other methods like numerical computing methods. So basically, as we know, the bisection method is a root finding algorithm which can particularly simple and robust. But however, its convergence is relatively slow as compared to the other methods. Like we can say, especially for functions with complex behavior. So, as if we compare the bisection method with Newton's method, we have some advantages and disadvantages. The advantage is it's faster convergence for functions with smooth behavior. And we can say another advantage with the Newton method is the quadratic convergence under certain conditions. And if talking about the disadvantages of comparison with Newton method, so it is requires like the computation of derivatives and sensitive like to the choice of initial guess. And if we compare this method with another numerical computing method, which is secant method, so in advantage we got that it doesn't require derivative information, and in its advantage, disadvantage is that it may fail, like due to converge, or like we can say the wrong solution. And another comparison with the false position method with bisection method is that it is similar to the bisection method, but generally in false position method it converges faster, and also it doesn't require derivative information. However, it can suffer from slow convergence, if the bracketing interval is large. And if we compare this bisection method with fixed point iteration method, so the comparison is like we can say it is simple to implement, and may converge like class of functions. So that's I was talking about the comparison with other methods of bisection. So in next slide we have like case study na. uh, uh, so case study in bisection method is it can solve a real world problem. Like we can explore any real world problem, and we can demonstrate how bisection method can be applied to the like you can say the approximate solution. And after that we are having its conclusion and key takeaways. So it have we can say its simplicity. Basically the bisection method is a simple and we can say a robust numerical technique for finding the root of a function within the given interval. Or another key takeaway is that it's bracketing method. As we know, it requires an initial interval where a function changes the sign. So that's all about the conclusion and takeaways of bisection method. Now Yasir will implement the code of bisection method and we will show to you.
Okay, thank you so much, Abir and Mohammad Yaya, for explaining what basically bisection method is in theory. And moving on towards the code, we have the bisection method code here, right here. First, we'll start off with defining a method called bisection method with a few parameters called function a, b, tolerance, and max iterations, which can be how many you want. For example, we have 100 here. And then we'll apply a if condition where if function a multiplied by function b is greater than 0, then it will raise a value error saying the function values at the interval endpoint must have opposite signs, because in bisection methods we should have one negative sign answer and one positive sign answer. And then we will apply a for loop for iteration for the max iterations, and basically this will run the program and run the iterations as many times as we have written here until we find the root. So to find the root, we use a formula where we use c as a variable. That c will be our root. C equals to a plus b divided by 2. So we'll use a if condition where if function c is equal to 0, or let's say b minus a divided by 2 is less than tolerance, then it will return us the c, which will be our root. And then we'll apply another if else condition where if function c multiplied by function a is less than 0, then b becomes equals to c, else a becomes equals to c. And then raise value error. If the first function fails, the first if condition fails, we'll raise a value error saying bisection method did not converge within the specified number of iterations. So that's pretty much the basic formula and how we will find out the bisection values and the root of the bisection. Then we have defined a print header for our program, and then we define another method for function input, which will which will ask the user for the input of the function. And then we use a variable called expression, and in that expression we write input, and the input will print out whatever we have to ask the user, and then we'll make it return by lambda function, and then we'll write eval and expression, so that it basically the input that our user will be writing in will be evaluated. And then we will make another method called interval input, get interval input, which will get the interval input of our answers, which should be positive and negative. So we'll ask them in float as well, so that our type will be of float. So the first one we'll ask the user to enter the left endpoint of the interval, and then the right endpoint of the interval, which will be a and b, and then we'll make them return our a and b. Then we come to our main function. We make the header print, and then we make it we print enter the function for which you want to find the root, and then our function will be equals to get function input. So basically we're calling the get function input method. We can write any function we want, and it will give us the root of it, and then we'll make it print enter the interval a and b where the root is expected. So we'll write interval a interval b equals to get interval input, which was our this a and b, and then we'll print solving for the root using bisection method, and then we'll use a try condition where we'll make it try root equals to bisection method, and then we'll enter the function interval a and b, and then we will print the root is x equals to, and we'll write in the root, and then accept value error as e, and then we'll make it print error e. And that's pretty much the program. Let me show you by running it. So since we run it, it's gonna ask us enter the function in terms of x. So any function that has x in it. So for example, we write the function x square minus 2x, or let's just keep it at 2. Let's just change it to 6, x square minus 6. Let's actually just change the sign, plus 6. Now it's gonna ask us the interval to write where the root is expected, so a and b. So let's start with the left one. Our left one will be, let's say, minus 3. Since one answer has to be in negative sign and one answer has to be in positive sign, we'll write positive 3. So solving for the root using bisection method, the functional values at the interval endpoint must have opposite signs. So it gives us an error if we don't have the opposite signs. And yeah, that's pretty much bisection method. And I hope you guys found our video interesting, and if you did, make sure to like and subscribe and comment down below. And thank you so much for watching our video, and take care, and Allah Hafiz.